This is the video demonstrations of water flow detection simulations. So we have here on the screen is the simulations program, and on the bottom right of the screen is where the sensor is mounted. The piezoelectric is mounted on a pipeline which connect to the tap waters that flow the water to the sink. So now let's go through the programs. So first I would like to start the program. So right now we need to follow the instructions, which is to open the valve at around 40%. And then we need to click the lower threshold button, and then the detection is start right away. So here I close the valve. There's no water flow is indicated. And then I just want to reset this button, these numbers, so that I can start the program and restart it again. So now there's no water flow at all. Let's see what happened when I open the valve. The LED is indicate that the water is flowing. And also you may have questions about these counter values. So let me explain this. So whenever the water flows, the counter is counting up, but then why is that? So the counter is only counting up if it sends the triggering signals, which is the water flow. But then the program has to make sure that the water flow happens during a longer period of time, which is not instantaneously, but there's some delay that it needs to be double checked against. So in this case, the counter will be counting up until 5, and then the LED will start lighting up, just like that. Okay. So using that, and also this value here state that I have opened the tap around 6 times. Let's see, can we achieve 10 times? 7, 8, 9, and 10. Okay, so that is and here is the stop button. So we can, whenever stop the programs, just click it. The program will be stopped immediately. Okay, let's start the program again, and we have another explanations for the calibration tab here. So it is the program operations. So here we have the acquiring signals that is plotted from the data acquisition board with a sampling rate of 40,000 sample per second, and here is the number of samples acquired, 4,000. So the durations of each signals will be 100 milliseconds, and here is the FFT of the signals, of these signals. So now there's no water flow, and then the signal is like this. So what happens if I open the valve? So here is that the signals from the frequency less than 6 kilohertz, you have the immediately high amplitudes. And also, based on that, we can find the detections if we have the filters that lie in front of this range, and we have the change in amplitudes. So right now I'm filtering the signals from 3.8 kHz up to 4 kHz, and this value is the amplitude of these signals, and this is where the detections happens. So whenever I press this button, this value will store this value. So this value will be keep in this controls, and whenever the next amplitude is coming, the program will compare this value to this, and if it is higher, then the detection is not the detection, but the signal is triggered the program and start to counting up the counter values. And if this thing keep happens again and again, then the counter is eventually higher than 5, which is indicate the water flows. So here, let's say the amplitude here is around like less than 0.01 volts, but here the threshold is 0.013 volts, so the result is no water flow. What if I press this button right at the moment? So now the low threshold is changed to very small values, so 0.005, so it is actually near this amplitude, so that indicates how to change the threshold using these buttons. In order to stop the program, this button will help. So now I want to stop the program. Stop it. So this is the end of the video demonstration. Thank you for your listening.